Hello everyone. Today we are going to discuss a circles chapter, subtopic normal to a circle at a given point. So already in previous sessions we discussed about the tangents to a circle at a given point. So it's the continuation we are discussing in this video. So today in this continuation, first we are discussing normal to a circle at a given point. That different forms of the equations of normal, different forms of the equation of normal, the equation of normals. So different forms we are going to discuss now here. So in that first form is point form. So the equation of the normal, the equation of normal at the point px1 comma y1 to the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0 is y minus y1 is equal to y1 plus f by x1 plus g into x minus x1. So if you look at the figure, so what is it mean? What is the normal here? So let's think this is a circle and this is the line, so which is nothing but a tangent to the circle. This is the tangent to circle. The line which is drawn perpendicular to tangent and passes through the center of the circle, is called normal, to the circle. That means normal is perpendicular to the tangent. So here we know center of the circle is minus g comma minus f, and the radius is root over g square plus f square minus c. So let's think the point of tangency or normal where we taken is px1 comma y1. So px1 comma y1 is the point of tangency, where we are drawn the normal also, where normal line is drawn, where normal line is drawn. Now see, this we know c minus g comma minus f, and this we know the point. So this normal equation is passing through this point P also. So that means equation of normal we can take like which is passing through x1 comma y1 as y minus y1 is equal to m into x minus x1. So this is the equation of the normal. Let it be equation 1. So if see here we got the equation of the normal and we need to find out this slope m. So how can we find the slope of this normal? So already we know the point C. So normal is passing through the C, and it is started from px1 comma y1. So that is nothing but the slope of the normal. So slope of normal m is equal to y1 plus f by x1 plus g directly. So let it substitute in the equation 1. So then equation 1 becomes like y minus y1 is equal to y1 plus f by x1 plus g into x minus x1. So this is the equation of normal in point form. So that is what point form of normal equation. Next comes to the second form. So parametric form, parametric form, parametric form. So in this parametric form, the coordinates where we will take the parametric form is a cos theta comma a sin theta, a cos theta comma a sin theta. At this point we have to find the parametric form. So equation of normal, equation of normal, equation of normal to x square plus y square is equal to a square at a cos theta comma a sin theta, at a cos theta comma a sin theta is, see, let's see how. So at x1 comma y1, at x1 comma y1, we know that y minus y1 is equal to y1 plus f by x1 plus g into x minus x1. So now this x1 comma y1, we are taking a cos theta comma a sin theta, and the center of circle we are taking 0 comma 0, which is minus g comma minus f. So if you substitute this all, y minus a sin theta is equal to what is the y1 here, a sin theta minus 0 by a cos theta minus 0 into x minus a cos theta. So after substituting the values, so this is the equation of the normal. So let's simplify this one. We'll get y minus a sin theta is equal to a sin theta by a cos theta into x minus a cos theta. So this is equal to, here a and a gets cancelled. So what we will get here is y minus a sin theta is equal to tan theta into x minus sin theta by cos theta into a cos theta. So here this cos theta and cos theta gets cancelled. So remaining is y minus a sin theta is equal to tan theta into x minus a sin theta. So both sides a sin theta cancel. So y is equal to, we can write this one as sin theta into x by cos theta. That means y by sin theta is equal to x by cos theta. Or we can write this one as y is equal to tan theta into x. This is the equation of normal in parametric form. Equation of normal in parametric form. So these are the two different forms, and in the slope form directly we will find out the tangent, and we will take in place of m we will substitute minus 1 by m, then we will get the normal equation. So let's see the questions based on this. So question number 1, first question. So what is the question we have here is, find the equation of the normal, find the equation of the normal, find the equation of the normal to the circle x square plus y square is equal to 2x, which is parallel to the line, x plus 2y is equal to 3. So let's see how to solve this question. So what they are given, the equation, first equation of the circle, what they are given is given circle equation. So they are given x square plus y square is equal to 2x. This we can write like x square plus y square minus 2x is equal to 0, whose center is 1 comma 0 and radius is 1. So since normal, what we need to find is parallel to x plus 2y is equal to 3. Since normal is parallel to x plus 2y is equal to 3, so that normal equation we can take like normal equation is x plus 2y is equal to some lambda. So this normal, generally normal, this normal passes through, normal passes through center of the circle like this. So this is the equation 1. So that means we can substitute the center of the circle in this line. So we'll get the lambda is passes through center of circle, is passes through center of circle. So that means 1 plus 2 into 0 is equal to lambda. So we'll get the lambda value as 1. So therefore, equation of normal is x plus 2y is equal to 1. So this is the way how can we find the equation of normal. So let's see another one. So another question is, find the equation of the normal. Find the equation of normal. Find the equation of normal to the circle x square plus y square minus 5x plus 2y minus 48 is equal to 0 at the point 5 comma 6, at the point 5 comma 6. So let's see how to find. So what is the circle equation they're given? So here given circle equation is x square plus y square minus 5x plus 2y minus 48 is equal to 0. So center of this circle is 5 by 2 comma minus 1, and radius will be root over g square plus f square minus c, that is 25 by 4 plus 1 plus 48. So this is the radius of the circle. We can simplify this one, which actually we don't require in calculating the equation of normal. So what is the equation of normal? Equation of normal when a point is given. Equation of normal when a point is given is y minus y1 is equal to y1 plus f by x1 plus g into x minus x1. Actually here x1 comma y1 they are given 5 comma 6, and we know the center as 5 by 2 comma minus 1. So this is nothing but minus g comma minus f. So from here g is equal to minus 5 by 2, f is equal to plus 1 we will get. So substitute here. So y minus 6 is equal to 6 minus 5 by 2. Okay, here y1 plus f, right? So 6 plus 1 by 5 minus 5 by 2 into x minus 5 into x minus 5. So let's simplify this one. Y minus 6 is equal to 7 into 2 by 10 minus 5 into x minus 5. This is equal to y minus 6 is equal to 14 by 5 into x minus 5. So multiply this side. So 5y minus 30 is equal to 14x minus 70. So if we'll simplify this one, so we will get, if we'll simplify this one, so what we'll get? 14x minus 5y minus 70 plus 30 is equal to 0. So therefore, equation of normal is 14x minus 5y minus 40 is equal to 0. Minus 40 is equal to 0. So this is the equation of normal. How can we find? Okay, right. So next we will see length of tangent from a point to a circle. So we'll see next topic, length of tangent. So next topic is length of tangent from a point a given circle. So let's see how can we find the length of the tangent. So let's see the diagram here. Let's see the diagram. So this is the diagram. Let's think circle. So there is a point P outside. From that point, we will draw two tangents to the circle. So one is this, and the second one is the tangent like this. So this is the another tangent we can take. So here the point P is some x1 comma y1 from where we are drawn the tangents. So these tangents are touching the circle at Q and R. So this is the center of the circle. So we're assuming the circle equation x square plus y square plus 2gx plus 2fy plus c is equal to 0. For this, at x1 comma y1, from the point x1 comma y1, if you draw the tangents, so length of the tangent we can take like length of tangent is root s1. So let's see how we will get this one. So this is what we have to prove here. So for that, let's see what is the solution for this. So here PQ and PR are the two tangents. Let PQ and PR are the two tangents, drawn from an external point, px comma y, So what is the center of circle here is minus g comma minus f, and radius will be taken like g square plus f square minus c. So let's we draw the lines here. So this is the one radius, and this is the another radius from here. So this is the another radius. So radius will be perpendicular to the tangent at the point of tangency. So like this. So let's we join this P and C. So it's become a right angle triangle. So triangle PQC become a right angle triangle, right? So triangle PQC become a right angle triangle. So in triangle PQC, we can write like PC square is equal to PQ square plus QC square. So PC is the distance between P and the center of the circle. So here we need the length of the tangent PQ. So PQ will be root over PC square minus QC square. So that is equal to PQ is equal to root over PC is the distance between the P and center, outside point and the center of the circle. That is x1 plus g whole square plus y1 plus f whole square minus QC is the radius, that is root over g square plus f square minus c whole square we have. So here square and square root will get cancelled. So we will get a plus b whole square here is x1 square plus g square plus 2gx1 plus y1 square plus f square plus 2fy1. So here it is minus g square minus f square plus c. So here g square minus g square, f square and minus f square gets cancelled. So we will get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So what is this actually? If you look at the diagram, this x1 comma y1, if you will substitute in the circle equation, s is equal to 0. So you will get like x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, right? So that is, we will denote like s1. So we can write this one as root over s1. So this is length of tangent drawn length of tangent drawn from an external point. An external point to the circle is root S1. So this is the length of the tangent, how we will find out. So let's see the question based on this. Let's see the question. So the question is, find the length of tangents. Find the length of tangents. Find the length of tangents drawn from the point drawn from the point 3 comma minus 4 to the circle 2x square plus 2y square minus 7x minus 9y minus 13 is equal to 0. So here one more thing what we have to discuss is, so we are drawn the two tangents from px1 comma y1 to the this circle, right? So the lengths of these two tangents will be equal. That means from an external point, if we have drawn the two tangents to a circle, the lengths of the two tangents will be equal. Means PQ is equal to PR. PQ is equal to PR in the above case. So let's see this question. So here we need to find the length of the tangent. So we know the formula is root S1. We know the formula is root S1. So before start solving the problem, always it's better to make x square and y square coefficient as 1. So that means you'll get like x square plus y square minus 7 by 2x minus 9 by 2y minus 13 by 2 is equal to 0. Let it be 1. So to this equation, from 3 comma minus 4, they are drawn the circles. So we are tangents. So we need to find out the length of the tangent. So what is the length of tangent? Length of tangent is root S1. So let's substitute this 3 comma minus 4 in the equation. So we'll get 3 square plus minus 4 whole square minus 7 into 3. I mean here we got 7 by 2. 7 by 2 into 3 minus 9 by 2 into minus 4 minus 13 by 2. So if we'll simplify this one, 9 plus 16 minus 21 by 2 plus 36 by 2 minus 13 by 2. So we can write this one as, so how can we write this one as? So take the LCM. So this is 25, it will become, so 25 into 2, so 50 minus 21 plus 36 minus 2 minus 13 by 2. So this will become 86 minus 34 divided by 2, which is equal to root over 52 by 2, so root 26. So therefore length of tangent is equal to root 26. Length of tangent is equal to root 26. So hope this problem is clear. So next, one more question on this. How they are given is, if the length of tangents from, if the length of tangent from f comma g to the circle x square plus y square is equal to 6, b twice the length of the tangent from f comma g to circle x square plus y square plus 3x plus 3y is equal to 0, then find the value of f square plus g square plus 4f plus 4g is equal to, find this value. So let's see how to solve this question. So solution for this one is, what they're given is length of tangent from f comma g to the circle. So let's we find out that first. That is, let's we think L1 is the length of the tangent, tangent, okay, from f comma g to circle x square plus y square is equal to 6. So that is root over f square plus g square minus 6. So x square, f square plus g square minus 6. Let L2 is length of tangent from f comma g to x square plus y square plus 3x plus 3y is equal to 0. So that we will take root over f square plus g square plus 3f plus 3g. So what they are given the condition, what they are given the condition here. So what they are given the condition. So the condition is L1 is 2 times of, here we took, this is L2. So L1 is twice the L2 itself. So what is the L1 we have here? Root over g square plus f square minus 6. That is equal to 2 times of root over f square plus g square plus 3g plus 3f. So let's we square it on both sides. So we will get g square plus f square minus 6 is equal to 4 times of f square plus g square plus 3g plus 3f. So let's we calculate, simplify this one. 4f square plus 4g square plus 12g plus 12f minus g square minus f square is equal to minus 6 will be same side. This will become 3g square plus 3f square plus 12g plus 12f is equal to minus 6. So take the 3 common from here. You'll get g square plus f square plus 4g plus 4f is equal to minus 6. So both sides, 3 ones are 3 2s, it is cancelled. Therefore, g square plus f square plus 4g plus 4f is equal to minus 2. So this is the answer for this question. So I hope this question also clear. So next, let's see how to discuss the chord of contact. What is meant by chord of contact actually? So chord of contact. So next topic is chord of contact. Chord of contact. So what is meant by chord of contact actually? So first I'll make you to understand this with a diagram. So if you'll see, this is a circle, and from an actual point, we know we can draw 2 tangents to the circle. From an actual point, we can draw 2 tangents to the circle, right? So this intersect the circle at 2 points. Let's think T and T dash. If I'll join these 2 points, so the line which joins these 2 points is called chord of contact. So definition, how can we write here? The chord joining the points of contact of the two tangents is called the chord of contact. So this is the way how we will define chord of contact of tangents. So how to find the equation of chord of contact? So let's we see, um, how can we take the equation of chord of contact is here. Let us assume, let the circle equation is, the circle equation is x square plus y square is equal to a square. So at the point t, let us assume this point is x dash comma y dash, and this point let us assume x double dash comma y double dash. At t, at t, equation of tangent is, equation of tangent is x dash plus y dash is equal to a square, and at t dash, equation of tangent is, equation of tangent is x double dash plus y double dash is equal to a square. So these points t and t dash are lies on t and t dash are lies on, from these two we can say lies on some x1 plus y1 is equal to a square. So here x1 and y1 are nothing but x dash y dash and x double dash y double dash. So finally we can conclude that, so this is the equation of chord of contact. So therefore equation of chord of contact, equation of chord of contact t dash is x1 plus y1 is equal to a square, which is also called tangent equation t is equal to 0. So this is the equation of chord of contact. So based on this, we have some points here actually. So let's we see what are those points. Some shortcuts we have. So in that note 1, note first point, if r is the radius of circle, if r is the radius of circle, if r is the radius of circle, if r is the radius of the circle, and L is the length of the tangent, length of the tangent from px1 comma y1 on s is equal to 0, from px1 comma y1 on s is equal to 0. Here that L is nothing but root s1, length of the tangent, right? So here L is root s1. Then first point, length of chord of contact formula direct, length of chord of contact, length of chord of contact t dash we can take like 2lr by root over r square plus l square, direct formula. Second one is area of triangle, area of triangle formed by the pair of tangents, by the pair of tangents, by the pair of tangents and its chord of contact, and its chord of contact is equal to RL cube by r square plus L square. So diagrammatically, I will show you actually about what we are discussing here. Okay, so these are the pair of tangents, right? So this is one tangent to the circle. So just assume, and this is the another tangent to the circle. So at this point, we can draw the chord of contact. At this point, we can draw the chord of contact. So that is this one. So see here, what they are telling here is area of triangle formed by the pair of tangents. Pair of tangents means this and this and its chord of contact means this. So this is the triangle which is formed here. This is the triangle which is formed. So area of this triangle direct formula is RL cube by R square plus L square. Next point number 3. Area of quadrilateral. Area of quadrilateral formed by the two tangents drawn from an external point from an external point to a circle and pair of radii through their point of contacts, is R into L. So that means, see, in the previous diagram, I will try to explain here. So we will draw the radius like this, right? So like this, we can draw the radius. So this is the area, complete area. So this area, complete area is the area of quadrilateral about what they are talking. So this is the formula to find the area of quadrilateral. This is a formula to find the area of quadrilateral. Next, how can we find the angle between the pair of tangents? Angle between the pair of tangents. Angle between the pair of tangents from Px1 comma y1 is tan inverse of 2LR by L square minus R square when L is greater than R. So pi plus tan inverse of 2LR by L square minus R square when L is less than R. So this is the fourth point. And fifth point, based on what we discussed till now. Equation of the circumcircle. Equation of the circumcircle of the triangle PTT dash in the previous diagram. In previous diagram is x minus x1 into x plus g plus y minus y1 into y plus f is equal to 0. So that means, if you look at this diagram, so that equation passes from here PTT dash, and this is center, so it will go like this. So the equation will go like this, and it is always passes through the center of the circle. That's why the diameter of this circle becomes the distance between this x1 comma y1 and minus g comma minus f. That means these two becomes the end point of the diameter to the circle which circumscribing the PTT dash. So end points of the diameter means, so this is the equation we can write x minus x1 into x minus x2 plus y minus y1 into y minus y2. So these are the different points what we can discuss based on the previous topics. So next, here we have one formula, one problem based on this. So the problem is, if the pair of tangents tangents are drawn from the point 4 comma 5 to the circle x square plus y square minus 4x minus 2y minus 11 is equal to 0. Then first question, find the length of chord of contact. Find the length of chord of contact. Find the length of chord of contact. Question number 2 under this is find the area of triangle. Find the area of triangle. Find the area of triangle. Area of the triangle formed by a pair of tangents and their chord of contact Next, third question in this, find the angle between pair of tangents. Find the angle between the pair of tangents. So let's see how to solve this one. First, let's take the information what they are given. They are given the circle equation. Given circle equation is x square plus y square minus 4x minus 2y minus 11 is equal to 0. And the point from where they are drawn the tangents is px1 comma y1 is 4 comma 5. So I need to find the two things here to solve the given question. First one is I want to know the length of tangent, which is length of chord of contact. That how we will get length of chord of contact. We have having the formula 2LR by root over R square plus L square. So we need to find the length of the tangent L here. So L, how you will get by substituting this point in this equation. That means 4 square plus 5 square minus 4 into 4 minus 2 into 5 minus 11. That is root over 16 plus 25 minus 16 minus 10 minus 11. So we will get this one as what we will get here? Plus 16 minus 16 cancel. 25 minus 21 4, which is 2. So under radius of the circle, we will get radius of the circle we will get center of this one is 2 comma 1. So 4 plus 1 plus 11 root 16, which is 4. Here L is lesser than the radius. So let's just substitute here to find out the length of chord of contact. 2 into 4 by root over 2 square plus 4 square. 2 square plus 4 square. So here what you will get is 16 by root 20, which is 16 by 2 root 5, which is 8 by root 5 units is the length of chord of contact. Point number 2, what they're asking, area of triangle formed with the pair of tangents and the chord of contact. That is RL cube by R square plus L square. So R is how much? 4 into 2 cube by 4 square plus 2 square. So that means 4 into 8 by 20. So which is 8 by 5 square units. The next one is third one. Angle between pair of tangents. So that is, we have, since L is less than R, we have pi plus tan inverse of 2, what we have formula, 2 LR by 2 LR by L square minus R square. So if you substitute the values here, pi plus tan inverse of 2 into L is 2 into 4 by 2 square minus 4 square, which is equal to pi plus tan inverse of 16 by 4 minus 16, which is equal to pi plus tan inverse of minus 16 by 12, minus 16 by 12. So 4 is a 4 4s are. So you'll get here pi plus tan inverse of minus 4 by 3. So we know that tan inverse of minus theta is minus tan inverse theta. So according to this, I can write this one as pi minus tan inverse 4 by 3. So this is angle between the pair of tangents. So hope concept is clear for this with respect to this problem. So next, diameter of circle. So how can we define the diameter of circle? So diameter of a circle. So generally, how can we define the diameter of a circle is, it is the locus of middle points of a system of parallel curves. Locus of middle points of a system of parallel curves means if I take the circle, if I take the circle like this, so let's say this is the circle equation. If I'll draw many curves which are parallel to each, so we can take like this. Okay, approximately we'll try to adjust. So one more line is like this, parallel curves. If you'll draw, if you'll join the midpoints of this all, so if you join the midpoints of this all, so this is called diameter of the circle. So how can we define it? The locus of middle points, of a system of parallel lines, a system of parallel curves, the locus of middle points of a system of parallel curves of a circle is called a diameter, of the circle, is called the diameter of the circle. So let us assume the equation of the circle is x square plus y square is equal to a square, and this one intersecting at a and b. So one is x1 comma y1 and another one is x2 comma y2. So here p becomes midpoint of AB. So P becomes midpoint of AB. Let us assume this is some h comma k. So h comma k will be x1 plus x2 by 2 comma y1 plus y2 by 2. So from here we will get this like x1 plus x2 is equal to 2h, y1 plus y2 is equal to 2k, right? So this points lies on the circle ph comma k lies on the y is equal to mx plus c. Let's think. So we can substitute this. So you'll get k is equal to mh plus c, which is equation 1. So substitute y is equal to mx plus c because in circle equation, because so that is intersecting the circle at two distinct places. So if I'll substitute y is equal to mx plus c in x square plus y square is equal to a square. So I'll get a quadratic equation. So x square plus mx plus c whole square is equal to a square. If I'll simplify this one, I'll get 1 plus m square into x square plus 2mcx plus c square minus a square is equal to 0. Let it be equation 2. So let x1 comma x2 are the roots of above equation, are the roots of equation 2. Then we will get x1 plus x2 is equal to minus b by a, means minus 2mc by 1 plus m square, which is equal to 2h. So from here we'll get h is equal to minus m by 1 plus m square into c. So what is the c value from equation 1? So from equation 1, c value we will substitute here. So what is that c value is? What is that c value is? H is equal to minus m by 1 plus m square into k minus mh. So if you simplify this one, you'll get h plus hm square is equal to minus mk plus m square h. These two gets cancelled. H plus mk is equal to 0. So this is the locus of ph comma k. This is the locus of ph comma k. So how can we write locus of h comma k? Locus of h comma k, ph comma k, that is diameter of circle is x plus my is equal to 0. X plus my is equal to 0. So this is the equation of diameter of a circle. Equation of diameter of a circle. So let's see one question based on this finally. So find the equation of diameter. Find the equation. Find the equation of. Find the equation of diameter. Find the equation of diameter of the circle. Of the circle. X square plus y square plus 2gx plus 2fy plus c is equal to 0, which corresponds which corresponds to the chord ax plus by plus d is equal to 0. So let's see how to find the equation of diameter. So the diameter of circle passes to the center of the circle always. We know that the diameter of circle passes through the center of the circle, passes through the center of the circle, and perpendicular to the chord ax plus by plus d is equal to 0. So we know that any line perpendicular to this one will be bx minus ay plus lambda is equal to 0. So this is passes through center of circle, So what is the center of circle here is minus g comma minus f. Let's substitute this here. So b into minus g, a into minus f plus lambda is equal to 0. So from here what we will get is minus bg plus af plus lambda is equal to 0. That is lambda is equal to bg minus af we will get. So let's substitute back this in equation. So we'll get equation of diameter. Equation of diameter is equal to is bx minus ay plus bg minus af is equal to 0. So this is the equation of diameter. So this is the equation of diameter. So next we will discuss a small point, and we will continue the remaining in next part. So last topic for this one. So that is two circles touching each other. two circles touching each other, touching each other, what happens? Two circles touching each other, what happens? So first thing, if the two circles touch each other externally, when two circles touch each other, externally, what happens? Externally, what happens? So let's we see, this is one circle, this is one circle. So, and this is the another circle. Let's we take, this is the another circle. So which touches so 1 minute, please. So let's we see, the two circles, let's we think they are touching like this externally. So let's we think center of the first one is a C1 and the center of the second one is C2. So if you'll observe clearly, distance between C1, C2 is equal to, if radius of this one is R1 and radius of this one is R2, so it will be equal to R1 plus R2. Distance between the centers is equal to R1 plus R2. So you let's think, if the two circles touch each other externally at the point P, P divides line joining C1 C2 in the ratio R1 is to R2. So let us assume here C1 is some x1 comma y1 and C2 is x2 comma y2, and this is nothing but m is to n ratio, P is dividing that line. Then how can we find the point P? By using the section formula. Mx2, here m is R1, mx2 plus n is R2, so nx1 by m plus n, comma R1 y2 plus R2 y1 by R1 plus R2. So this is the way how can we find the point of intersection of these two circles when touch each other externally. So these are the coordinates of P. Therefore, coordinates of P. So next, point number two. When two circles touch each other internally, if two circles touch each other internally, then how can we find or we can say, like, if the circles are like this, okay, so another circle is like this. When two circles are touching each other internally, so this is the center of first one, this is the center of second one. So radius of first one is R1 and radius of second one is R2. So very clearly, when two circles touches internally, so clearly we will get it to know that C1 C2 is equal to mod of R1 minus R2, means distance between the centers is equal to difference between the radii. So here the point P will be here. So again, P divides R1 R, P divides the line joining C1 C2 in the ratio R1 is to R2 externally. This one is this is internally it is touching. So this is for internally, and this is for externally. Next one is for external touching. So externally, the point of contact. So here it is, point of contact is external contact. So this is external contact. This is externally division. So here, how can we find the P's? So R1 X2 minus R2 X1 by R1 minus R2, comma R1 Y2 minus R2 Y1 by R1 minus R2. So this is the last topic for this video. Thank you all. So those who are not subscribed my channel till now, please subscribe to my channel and support my channel for more videos. Thank you all.